Question: can you run old ROMs on a SYM-1 without using the original eeproms? Well, the answer is yes, you can. Well, that was easy. See you next time. But honestly, this journey was really complicated, and I'm going to show you how I got from nothing to running ROMs on a SYM-1 without any of the original ROM. So the story begins last March. I decided to get back into programming calculators, so I bought a TI-83 Plus Silver Edition. I got this one because it works on my keyboard stand, and there's an on-calc assembler called Mimes that works great on it. So I used this so I could learn Z80 assembly. But as you can imagine, it's really difficult to program on a calculator. You have no tools like copy and paste, and you're not just learning Z80 assembly, you're learning all the ports and subroutines of the TI OS. And mind you, I didn't even know what a port was at this time. It wasn't until much later that I finally figured out that it was just a location in memory. I don't remember how exactly, but an older coworker of mine offered to give me his old minicomputer from the 80s. It's called a SYM-1 and is a clone of the KIM-1, but it had more I/O chips and a full 4K of RAM. When he showed me the computer, I had no idea how to make it work. He turned it on, hit some buttons, pointed at the 7-segment display and said, "Hey, there's your prompt." It looked like complete gibberish. Over the next few months, I learned how to program the SYM-1 on the hex keypad. But, eventually I wanted to send larger programs, and keying them in this way was not feasible. So from this point, my goal was to connect the SYM-1 to a terminal. But it was not easy. Turns out, after literally a month of failure, I had to send a queue over to the SYM via terminal before anything else. Then the prompt would show. So now I had a terminal. Next up, I wanted to put BASIC and the resident assembler editor onto it. So I knew that these ROMs existed because there is some literature left in the box from my coworker had this computer. I knew I wanted these ROMs, but there was no way I could get one now. Most likely, all the original eeproms have been lost to time. Now, the reason I couldn't just buy new eeproms is because these particular eeproms were not made anymore, and they are fairly rare, and blank ones are considered fairly valuable. But interestingly, the ROMs are Intel pin compatible. This means that modern eeproms, like the popular Atmel series, will work as a drop-in replacement. These are the 8K sized Atmel eeproms. However, there are too many pins on this ROM because the original ROMs did not have the read, write, enable, or erase pins. They used UV light, or no light at all if they were PROMs. So my friend and I came up with these. These are modern PLCC Atmel 8K ROM chip to DIP socket adapter boards. Simple, so now all we have to do is program the EEPROM, and then put it in the socket, and it doesn't quite work. Turns out, the sockets that the SYM-1 uses are single wipe. There are contacts on the outside of the legs, but not for the inside. Because they're meant to hold actual chips, the bent out thin legs of those chips will work. But if you use straight breadboard pins, there isn't enough tension for a snug fit, and it can wobble loose. Worse yet, if you jam down, then the fat pins of the breadboard pins will permanently bend the leaves of the socket. What I wish is I could find a chip like this. Thin dip legs on the bottom and a breadboard adapter on the top. This won't work, however, because this is a microcomputer version of the Motorola 6800. There's 128 bytes of RAM on board, 4 PIO chips, and a backpack area for 2 to 8K sized ROMs. So after a lot of thought, I finally figured out that I need a different solution. This here is a RAM expansion board. It slots in the SYM and the E connector, and according to your bank selection, it fills that 4K address space with RAM. This isn't the first idea for this sort of expansion. Back in the day, my coworker tried to take this Intel memory plane and attach it to the SYM in a very similar way. But back to this one. I thought, what if I turn on the sections of RAM that match the sections of the ROM taken up by the original EEPROMs? The exact memory location is important. Inside these programs, to save a bit of space, they contain absolute jumps. So the subroutines are hard-coded, and short of reassembling the entire program, I can't do much about this. I just recently made a video on how to take Intel hex object code and convert it to paper tape for the SYM and KIM-1. So I will be using the bones of that project to create this new one. With this tool, I create a paper tape file. It's super long, but that's because of how big these ROMs are. If we were to take actual paper tape, it would be really long too. In fact, here is the 4K basic tape for my Altair 8800. With the RAM expander plugged in, I set the character or line delay options in real term. I choose 20 and 50 milliseconds respectively. Then I choose the paper tape file, enter my load command, and then I hit send. Remember how you said that the paper tape file is long? Well, to send the basic paper tape file over, which is 8K, with 20 milliseconds for character delay and 50 milliseconds for line delay, it takes a cool 12 minutes and 43 seconds, or about half an anime episode. So once the transfer is complete, we can verify this by checking the RAM. If we check location C000, we can see that the start of the program does reside in this location. If we check the end, we can see that the last 4 bytes of the program are zeros, which is correct. So let's run the program. Well, as you can see, we are greeted by the memory prompt. Let's just hit enter for both the memory and for the screen size, and we're in. Now let's try to make the Hello World program. This is running on the SYM-1 on a 6502 processor at 1 MHz. It's quite a bit slower than my 18 MHz C180 computers, and even slower than the Altair 8800 emulator. But this is Microsoft Basic nonetheless. Now let's try the RAE. So I go through the same sequence to load this into the SIM. And there we go, we have it up and running. Now I don't really know how to use this program, but what I think this lets you do is have a line-based editor for an assembly program, and then you can assemble your code. I don't think you can jump to it and run it from inside the program though. I think you have to exit it back out, and then you have to, I think you have to pipe out the file into a paper tape, and then when you want to run it, you have to pipe it back in over paper tape to test it out. There we go. I needed a .en at the end to mark the end of the file. It assembles now. And that's it. This was a very long process in the making because I had to start from basically zero understanding of how old microcomputers worked. But, with modern ingenuity, it goes to show you that, even if you don't have all the original hardware, you can still, step in a time machine and relive a simpler, more basic time.